Welcome to this video where we're going to look at how to use named templates in Helm. They're sometimes also called subtemplates and sometimes called partial templates. And really this is the point where you get to structuring your templates. You can write fragments of template that you can reuse across multiple templates. So you can sort of write your own library of useful template fragments. Very powerful. You're going to see this used a lot in professional Helm templates. Maybe you've landed on this video, in which case welcome, and I hope you'll find the material here useful. But be aware that this is video 14 in a series of 15 videos. Since video 10, we've been building our own Helm chart template. For the first 10 videos in this series, we were getting to grips with Helm and understanding Helm. So actually, if you're new to Helm, you might want to go right back to the start of this sequence of videos, and there is a playlist below. Also below is a link to my commercial courses. You can buy my 30-hour Kubernetes course, and I've also got an Istio course as well, which I reckon is probably the most understandable course on Istio out there. I try to avoid using too much jargon on that course. But if you're here for named templates, then let's get cracking. Now, a subtemplate is a block of YAML that you want to reuse again and again and again and again across your chart. Now, what we've done so far is useful, very useful, in that we can use this action and we can reference values that are stored in the values.yaml file. But that's only useful for single values, really. When we want to reuse an entire block of YAML, then we need a different construct. So as an example, again, I'm making up requirements here. Let's pretend it's the case that this block here, line 16 through to line 18, where we're defining what image we want to use for this particular pod. Let's imagine that for some reason this block is used all over the place in our system. We've got thousands of lines of YAML in this chart, and this block appears again and again and again. We can't move this block into the values.yaml file. That just wouldn't work. But what we can do instead is move it into what's called a subtemplate. Well, actually, according to the documentation, technically these are called named templates. It depends on who you're talking to. Some people call them partials, and I'm in the habit of calling them subtemplates. I think for the purposes of the video, I'll try to stick to named templates from now on, but you might hear them called any of those three things. Now, I'm not going to go into the full detail of how to work with named templates because this section of the course is getting quite long now, and what I really need you to be able to do is to understand the basics of this, but perhaps more importantly, I want you to be able to recognize what's going on if you look at a pre-written chart. If you need to look at the source code for a pre-written chart, it would be really useful if you could understand what's going on here. Now, the idea of one of these named templates then is we can effectively rip out an entire block of YAML, and it doesn't matter how long that YAML is. And I've just done a cut there, so I've got that text on my clipboard. And I'll put in a comment here to remind myself that we need to substitute some YAML here. We'll see how to do that in a short while. I'm going to move that block. Now, this is going to be in the templates folder. I'll create a new file in here, but there's a really important concept coming up now. Now, I'm not entirely sure yet exactly what to call this file, but we might call this file something like commonblocks.yaml. When we go a bit further with this, you're going to see that we can put more than one block into this file, and that's why I've called it commonblocks plural.yaml. But there's a big problem with this idea. You've seen previously that what Helm does with this templates folder is it takes every YAML file it finds, it processes every YAML file, and then applies it using kubectl apply. But for this common blocks, we don't want it to do that. we want it to just use the contents of this as a kind of library. It's probably best if I try to just go ahead and make it a regular YAML file and put in our common block of YAML right there. The problem is, if we now run this through Helm template, it's going to crash. It's crashing because it's thinking that this commonblocks.yaml is a regular first-class YAML file. Well, of course, there's missing structure here. There should be a parent key here, and, it's just a fragment of YAML is what I'm trying to say, but it's trying to treat it as if it's a full YAML file. This is a good opportunity to give you a bit of advice here. When you get these problems, these YAML parse errors, it can be really confusing to understanding what's going on here. But as they advise here, if you rerun the command with the --debug flag, now we're getting a horrible big stack trace here, which really isn't helpful. But you can ignore that. If you go a little further up, it's showing you, let me highlight the relevant parts. It's showing you here the YAML that Helm is trying to generate as a result of our input. So you can see that it's pulled in our Fleetman full YAML file, and that's all looking good. But then, going towards the bottom, it's picked up commonblocks.yaml and it's tried to put that into the output. And you can see this is just not valid YAML at all. We don't want it to treat this as if it were regular YAML. We want to treat it like a library. The convention that Helm uses is a bit strange. We rename the file and we prefix it with an underscore. And the presence of the underscore tells the processor to ignore that YAML file when it's building the template. So now if I go back and rerun that command, and I won't use the debug this time, can you see this time it's run through absolutely fine. It's just picked up Fleetman full and it hasn't done anything yet with that fragments file. Now, it turns out, actually, the extension's arbitrary. We could put any extension we like in there. It doesn't have to be .yaml. And there is a convention amongst Helm charts that whenever you're writing these libraries, we use the extension of .tpl, which I guess stands for template. It makes no big difference. I guess one of the reasons for this is so that it stops your editor trying to interpret this as being a full valid YAML file. It's not that important, but I suggest you follow that standard of using .tpl here. When we go a little further, we are potentially going to be adding further common blocks into this file. You can't make this YAML block kind of just float in midair. You need to wrap it around some Go in order to make it become a named template. And the way we do that is by using the define command. That makes this be a named template. It's a function and it takes a parameter. And that parameter is simply whatever we want to call this block. Now, I'll talk about naming conventions here in a short while, but for now we can just give this block a label such as, I don't know, the web app image maybe, and we end the block with end. So with that in place, we now have a named template that we can use repeatedly across the entire project. All that remains now is to show you how you actually pull that in to our target YAML file. Now, there are two ways of doing this. There are two commands that we can use here in our main YAML file to bring in that common block. We have a choice of two commands. We can either use the template command or the include command. Both of these are very similar, and I suspect it's just a bit of a historical thing with Helm charts that they've provided two almost identical commands. It turns out that although the two commands are almost identical, include is more useful because it can do one thing that the template command can't. I think in theory, you could ignore the template command and always use include. The reason I'm covering both of them on this video is not to bore you, but it's because you're very likely to find instances of the template command if you're looking at any pre-written charts. And I want to show you them both so that you recognize them both. So really, you can always use the include command, but you might see the template command out there in the wild. So I'm going to show you first of all how we can use the template command. And again, it's another go action. So in the curly brackets, we'll use template first of all, and then I'll show you include. There are two parameters into template. The first of them is the name of this named template, which for us was web app image. And the second parameter is slightly harder to explain. If we go into this name template, remember we are using lots of values here, such as Docker repo name and the development Boolean flag. You know that these are coming from values.yaml and they're in the form of a tree. YAML, after all, is hierarchical. Now, this parameter here, this second parameter, is saying at what part in the tree do we want to start from? It's kind of hard to explain that. What I mean is if I put a dot in here, and that's probably what we're always going to do, then in the name template, the parser has to start from the very top of the tree and it works down through .values and so on. We could in theory say the top level is going to be .values, and then in this block, we wouldn't need the .values in front of all of the values. Now, if that's confusing to you, don't worry. We can always just specify just a dot here. And then in your name templates, just always work from the top level. I think this is an instance of where they've overcomplicated things, and in practice, people don't really use that feature very much. Hope that makes sense. Let's see if this works. Back on the command line then, we'll repeat our Helm template process, and we didn't get any errors, so that's good. And what we want to look at here is the structure of the YAML that has been output. So that's the comment that was present in our main file. And then the next line is where we brought in the name template. And you can see that it actually has brought in that name template. And really importantly to notice is that it has also executed the code inside the name template as well. We've got the correct image name and we've got the correct tag appearing. If I were to repeat the template command with setting the development value to true, then you can see there that even though it's now in a name template, it's still appending -dev to the end. So this is kind of working, but it's still not up to a professional standard. There are a couple of problems with it, and all the problems are based around white space. The first problem, and the easy problem to solve, is you'll notice we've got a blank line here. And we don't really want a blank line. It looks at first as if this block isn't kind of connected to this containers tag when it actually is. Well, I think this comment that I put in here isn't very helpful. I'll remove that entire line. So it looks at first glance like, yeah, this name template should be appearing directly underneath the containers line. But it isn't. We're getting a blank line. Why is that happening? And the reason for these annoying blank lines is where we have a go action, such as here, what's happening is that once the processing has been done, there's a blank line being left behind where that Go template has been removed. Essentially, it's running this template, it's pasting the results underneath, and then it's removing that line entirely. You're going to find that happens a lot. Essentially, it's wherever you have a Go action that's taking up an entire line of its own. It leaves behind a blank line, effectively. And you can very easily get rid of that. You use a directive in the Go action. It's just a minus sign after the curly brackets. And this means it's going to remove any white space that's resulted from this action. And white space means any spaces, carriage returns, new lines, and that kind of thing. It turns out that, I don't know why, but for some reason, this line and this line aren't actually leaving behind any white space, but you'll find most template developers will go and put this dash in any of these Go actions that happen to be taking up a full line. You'll see that that's pretty common. So it's quite simple, really. Whenever you see blank lines, it's probably because you've got a Go action that's leaving a blank line behind when it has been processed. Just use this dash sign. And if we check the difference now with Helm templates, you can see now, I hope, that that is looking a lot better. It's looking a lot more like professional YAML. So that's one of the problems. That was a minor problem, really. The next one's a major problem. And the problem is I have cheated, and I've cheated quite dramatically with what I've done. Well, before I get into the deep explanation, let me first of all say that I just put this action to bring in this name template. I just kind of put it at a random level, really, on this line. However, it's pretty irrelevant where this action appears. I could put it right here on the far left, and you can see the output's the same. I could have it hanging in the middle of nowhere. Same result. So bear that in mind. The big mistake I've made here, really, is I've made a big assumption. Can you see in this library, I have hard-coded in the size of this indent. It happens to be, I always get confused with YAML, it's 8 spaces to image here, but actually the important number is how many spaces it is to the first character here. That indent is 6 spaces to the dash sign here where we're starting the YAML list. So it's a 6-space indent. The huge problem is that works perfectly well here, because in this situation, the position where we want this block to appear, which is exactly 8 spaces in. Well, of course it is, because remember, I just cut and paste it out of here. But it works here. But remember, we're going to want to use this template all over the place in lots and lots of other parts of the YAML. And we have no way of knowing if 8 spaces is going to be the correct indentation in the rest of this file. It will absolutely depend on wherever it's being used. So I deliberately did this, but in practice, there's no way we want to be hard coding any indents into here, because we just don't know how many indents are going to be needed. Really, in practice, we would want to have this file looking, and let's get rid of that comment. That's not adding any value anymore. In practice, we would want the common block to be defined like this. And what we want is we want the end user, if you like, the point that this block is being used, where it's being brought in. We want to be able to set exactly where this block is going to be positioned. So this now, the common blocks file, is now a lot more professional. But you can see the problem now. It is going to be, of course, now rendering that YAML in the wrong place. Let's prove that. If we run the Helm template command again, we're now getting a YAML parse error. Now, we've seen this before. It's because the YAML that it's generated is now failing, and it's falling over. And we definitely here would want to use the --debug flag to find out what's going on. And that's one of the most useful things you can do, to use that debug flag. As before, ignore this call stack. That's all Go. What we definitely want to look at, though, is the generated YAML. And that really tells the story. We can now see the indenting is all wrong. It's now on the hard left. We don't want that. We want it indenting in. And as I mentioned before, it's no good trying to move this around, because that will have no effects on the output. So, you know, I could try maybe putting this into the right position, but no, we're still crashing and it's still appearing right on the left-hand side. So how do we solve this problem? At the point that we're bringing this named template in, the user of this template decides how deep they want it indenting. Now we know at this point that it is indeed 6 characters that we want to indent. And I did miscount that earlier. I'm sorry about that. It is 6 characters that we want the resulting name template to be indented. And in theory, we can simply, and this is where one of those pipeline functions come into play, we can pipe the results of this name template generation into a function called indent. And the indent takes one single further parameter, which is the number of characters you want to indent by. Now, I get a bit confused here. Sometimes I think it's the number of levels that we want to indent. I think it's actually 3 levels that we're indenting here, but because we're using 2 characters for each indenting, it's going to be 6 characters. So we need an indent 6. Now, I said in theory, and the reason for that is let's run it and we will find, and I'll run help template here without the debug, we'll find quite an obscure crash. And I'm not even going to bother with the --debug because it doesn't really help here. Now, this is the point where I can explain the difference between templates and the corresponding command of include. Now, I don't know the deep reasons behind this, but the difference between template and include is they're identical, except when using include, you can use it in a pipeline. So really, for me, that means the template command is redundant and you can always use include. As I mentioned before, I've shown you template in case you come across it in practice, maybe in some pre-written charts, but you're absolutely fine to always use include. I think there's some kind of historical reason for those 2 commands existing. Anyway, it's a simple change. I'm back to the command line now. Again, I'm going to run without debug in place. And this time we are getting a valid output. And can you see now that our block, our named template results, is appearing in exactly the place that we want it. So that means now whenever this name template is used, the user of the name template can decide exactly where they want it placing. And that's how it's done. So I think we'll wrap this video up here. You can go quite a bit further with these name templates, but there's definitely enough to get you started there and probably enough to get you understanding professional pre-made charts. And that's what we'll do in the next video, I think. We'll have a little look at pre-made existing charts. I'll see you for that.